Good morning, Tony. How you doing?
Good morning.
How's the weather in Florida?
Uh, Rain, rain, and rain, but not as much as you guys have gotten.
Yeah, we got
I don't know. We've gotten as much as I. Some places got 4 or 5 inches in an hour. I mean, it's really heavy down here.
yeah. Yeah, we got hit by that big flood that actually ended up taking the lives of quite a few people, which is a bad deal. So we just pray for them and their families and everything. But anyway, so our last conversation, we were on the subject of reeds and reed cages. We had ended up Um, on that subject, we had ended right around the talking about what you used as reeds, and then you were talking about different thicknesses and different materials. So I say we just take off from there.
Okay, yeah. I've over the years, I started looking into getting material made by the different plastics companies. Then after that point, I started getting in contact with the different engineers because most of the stuff's all designed for printed circuit board, has really no bearing on a two-stroke engine at all. And some of the, without knowing the epoxy laminates and the prepregs and the different compounds that are put into the epoxy, uh, you kind of it's kind of a give and take on what works, what doesn't work, what fails, what doesn't fail. So I probably have 20 or $30,000 worth of reed material I've thrown out over the years that I've tested that didn't work. That
Mhm.
worked, and you put it in the motor and it would delaminate. And I had a lot of issues with that until I started physically learning all the, I should say, all the epoxies that were available, all the type of epoxies. Um, and then work with the engineers to figure out what was the best oil, heat resistant, oil resistant, what would work best for what we're using, and then design my own materials. Uh, when people always go to, they tend to mention as thickness. That really isn't relevant. I literally have material that's 20 thousandths thick, and I can blow on it and it'll open. And I have 6 or 7 different 20,000 stick reeds. And when I get to the very coarse weave cloth, you almost can't pry it off with a screwdriver. I use the coarse weave stuff for retainer strips. Sort of like the little metal Boyson strip to hold the reed down.
Mhm.
Some of the reeds I make for different companies, I make those strips out of a 35,000 stick, really coarse weave, extremely structurally strong. That's like woven on a boat. That's the structural material, and that's usually 6K, 3K, and you start getting down into the finer weaves of 1K, and all these things are what they call prepreg, which means plastics companies buy the material from a company. It's refrigerated. Its press thickness is known. Its chemical properties are known. There's different epoxy combinations that could be ordered. And once I learned all that, I could tailor exactly what I needed.
Gotcha.
Um, Back to the thickness. Everybody always refers to the thickness as a tension. In other words, 12 thousandths reed is very light tension, and a 20 thousandths reed is very thick. What I did is I have a special Wagner gauge that I used to supply all the big motor builders that really wanted to be on the same page as I am. And when we get into testing reeds, if you get into testing reeds or anything, I'll set you up with that same gauge. You measure the reed lift at 10 millimeters, and you tell me how many grams it takes to open it at 10 millimeters. Then I can compare apples to apples with what you have on your end and what I have. You could tell me that something has a specific tension, but how do we calibrate your measurement versus my measurement?
Right.
And that's how I did it. So once I learned someone had reversion or had an issue with reeds, I would send them that gauge. They would measure it. Then I knew exactly. what they were talking about intention wise, and then I would alter my materials or alter the design or alter the backup tensioners that I would put on the reed cage to make it work.
So
You know, and
you created a read standard testing tool so that you had a common frame of language.
correct, exactly. That way I know exactly what tension you have, and then we start working with that. Once I learned all that, that was the controlling factor of making a very good product that lasts. Um, some of the biggest issues when I raced a lot of road racing, so I was privy to a lot of the TZ 250 stuff. Um, there were certain TZ reeds that would just shred reeds, no matter what material I put into it. Literally, once you look at it, the reed cage was so far into the crankcase that the tip of the reed would open up on the top reed and a piston would come down and literally would touch it. That is how deep they had it set in. I made what did I make it? I think it was a 1/4 inch, 6 millimeter spacer, and basically changed a little of the characteristics of the bike, but not much. But it ended the reed problem.
Mm-hmm.
Reed cage positioning is very critical as well. I can get into other tests and things later. Today, like I said, we're talking materials. Once I use the different materials, most of my reeds are multiple laminates, meaning I may have a thicker core in the middle and thinner cores on the outsides. A lot of the carbon reeds I make are basically they're a carbon reed with multiple layers of clear or multiple layers of fiberglass reeds on top of it.
Mm-hmm.
Some carbon I have is strictly carbon and resin. Um, I found that making just once I learned how all the composites work together in creating what worked as far as tension wise, and then I went to what's going to work tension wise and last longest.
So when you're doing this, and I'm gonna sound like an internet idiot right now by saying this, but when you're actually running your dyno tests and you're testing your different reads,
Mm-hmm.
what pattern are you looking for to know that you're headed in the right direction with the reads that you're using?
Yeah, I mean, of course, I could put a extremely low tension reed in there. Um, and this was 30 years ago when I did this. Uh, Probably a 12,000 stick reed, 2 plies, thin, no tension at all. You could put it in there, and the motor will actually come up to its RPM, power peak, and the crankcase stuffing would completely go to almost negative at that point. Even though the motor's still running, you would hear it basically 4-stroke. It was too rich. You'd see this giant plume of fumes come back out of the carburetor.
Mm-hmm.
All the tests were done on a dyno with no air filter on it, so I could observe I call it the plume out the back of the car.
Right.
And then once that happened, I mean, that really thin, low tension reed, it would go up, it would gurgle, it would start to clean out, it would actually, you see the reversion go back in, the RPMs would come up, and then it would just cycle like that. And it had lots of low end power, lost mid range, lost top end. And if you keep going up in tension on the reed, it'll go from all bottom end, no mid range, no top, and then it'll just start getting to a point where it'll lose a little of the bottom, but it will gain really good mid and maybe sign off just a touch on the top. And as you go a little more tension, you'll get the best overall performance. And then as you keep going stiffer and stiffer, that low end and mid range goes away, and you'll get really good top end performance. And then finally, when you get it too stiff, it'll just be literally no performance at all because it's not allowing any of the fuel to get into the engine.
Gotcha.
And it's a balance of how much there's a very critical balance of how much fuel that reed cage will allow to go into the motor. At the same time, when the crankcase volumes build up, it will be able to slowly shut back down and restrict that flow as well.
Mm-hmm.
So it's just a fine line in between that.
So, since the last time we talked, and we were talking about the ability to visualize what's coming out of the back of the carburetor, I purchased one of these endoscopes, which has got a light on the end of it, and set it up where it would go into my plenum box on the dyno and look right at the back of the carburetor. And so now what I'm doing is recording that, and I'm starting to put together basically, I've only done it on one engine that we did this last week, but I could see at the different parts now. And I put a small RPM gauge in there too, a digital RPM gauge, so I can see as it's counting up
Oh, really?
RPM when it's starting to wash back. So once I have enough data collected on different engines and how they're running and everything, then we'll get together and observe the video and see. But yeah, I mean, this was like a $15, $15 piece to record data that this now should answer me some questions, because since where you're doing it with the filters off, you could visually see it, but I couldn't see it inside the box. But now I have a way of seeing inside the box. I just wanted to show that to you.
Right, sure. Oh, I know. We talked about that, and that's brilliant and perfect. And yeah, like I said, mostly what I do is road race, so I don't work with air boxes. I am working with two different road race bikes that I'm doing the plenum air box with just a paper element over the top. And yes, then I can actually go in there and do exactly what you did. And the reason for the air boxes, what I'm doing now is we're doing ram air.
Yes.
I'm doing cold ram air induction. In other words, I've got two NACA ducts in the fairings that run to tubes that go to the air box, and it pressurizes the entire air box. And that's another whole story. And I'll be testing that. I started to test it this weekend, had some dyno issues. So and as we talked earlier, I'm also upgrading on my dyno as well to just have a lot more data, be able to store a lot more data.
Right. Yeah, I cannot stress the fact that, and like I tell everybody, I've got a massive amounts of sensors, and I may not understand. I may be collecting data right now that I don't understand how it correlates, but at some point I will, and I'll have that huge library of
Mm-hmm.
information to look back at and then establish the patterns. So much in life, and I'm sure that you'll agree with this, but so much in life is just finding the patterns in things. Being able to hear, we were talking about this the other day ago, about being able to listen to a bike go by and see somebody riding it by and being like, okay, this is what needs to be done to it. Tell the story about the carbs,
Which one?
with the slides.
Oh, okay. Yeah. Yeah. Went to a shop in Georgia one day for a dirt drag race, and I see two of the mechanics on the other side of the shop, and they're fiddling with this bike, and it's running. And then I hear them go out for another test drive, and I'm talking to the owner, and I'm 50 feet away, and I just yell across the shop, "The slides are in backwards." So the mechanic comes over, and they're over there discussing, kind of talking, and they're like, "There's no way." All of a sudden, I see them working on it, and I hear it fire up, and it's perfect. And they walked over and they said, "How in the world could you know that the slides were in backwards 50 feet away?"
Yeah, well, because you'd heard it
Many times.
before.
Yeah, I've heard it before. And I've done that. Just means that I did it at one time and I learned from it.
Right, exactly. Learning from now, just to answer the question, because of everybody out there. Well, you can't put the slides in backwards on Banshee OEM carburetors. They are
Yes.
right and left side, and you can flip them around and put them in backwards. You can do that on
Exactly.
OEM carburetors. On like a standard because they use a round slide Mikuni on a standard round slide Mikuni. You can't, but on right left side carburetors, you can get the wrong slide into the wrong side, and then the cutaways will be pointed towards the engine side and not towards the air incoming side. But so before anybody out
Exactly.
there says, "Oh, you can't do that," yeah, you can.
Yes, you can. And Mikuni round slides for the snowmobile market are available in right and left 30, 32, 34s, and you can reverse those as well.
Yeah, yeah.
But most
So
of the time, people don't buy them that way. They buy just two of the left hand carbs and the idle screws in the middle where you can't get to it. Um, but if you know enough and you know the right part numbers, you can get a right and left round slide carburetor as well. Anyway, back to Reed's intention. Yeah, it's just been 20, 30 years. It seemed like every time I get a really good company that makes the material, they would end up going out of business. And then I have to search for another. And I've had one for about 15 or 20 years now. Work with the engineers. Everything is perfect. They're a great company, you know.
so finding somebody that would be at the supply end of the thing has been a bit of a problem.
It's been a massive problem. I'm talking, that's where a lot of my material that I threw away is I couldn't find companies that had what I wanted and was, all right, well, this is the only thing I can get. What do we have? And I buy, of course, they're like minimum 10 sheets, and, okay, there's $1,000 or $2,000 worth of material. And then it's junk. And what do you do with it? Throw it in the garbage,
Right. And I think you and I have talked. Are you experimenting now with laying up your own materials?
Yeah, as test materials I can. I'm learning all about carbon infusion, carbon vacuum bagging, carbon infusion. The way these materials are made now is there's a 3 foot by 4 foot surface ground plate of steel, which is about 1 inch thick. And there's a top and a bottom, and they heat that steel plate up and it comes down and it presses all the material together. They can do, I'm not sure how many sheets they can stack, but they typically stack, I think, four to stem ply in the middle, and then they put these, like I said, surface ground steel plates down, and they're heated to a certain temperature to cure the epoxy resin
Hmm.
and they hold that temperature for a certain amount of time, and then they undo the platens, and then they take the sheets out and they send it to me.
Gotcha.
And those machines are extremely, extremely expensive. But I get 3 foot by 8 foot sheets. Now, I had a 3 foot by 3 foot CNC router running everything so I could run the bigger sheets. Um, that therefore I could use the bigger sheets. Now they make small tabletop presses, which their engineers use to do all of their experimentation and testing. Those are fairly reasonable, and I'm pretty sure I'm going to end up going the route of once I learn a little more about the prepregs and epoxies and what I am doing. I probably will buy a smaller version of that and be able to create my own reads in house as well.
Well, so yeah, that's the thing is being self-sufficient in today's world as much as possible allows you to continue your pipeline without getting hung up by somebody else.
Oh yeah, I mean, I did reed valves. Most people don't know it. I did reed valves. I could almost say, other than Carbon Tech and Boyson bought Carbon Tech a while back. I mean, like 20 years ago. Um, Basically, if there's a reed valve out there and it's not one of those two, I probably make it. I had my CNC router running 12, 14 hours a day, 16 hours a day for years and years and years, supplying virtually everyone else in the world with reed pedals. And that's where I made all my money and was able to do what I do is I made reeds for everyone, you
Mm.
know. And a lot of times I don't name the names because A lot of times I have proprietary contracts with them. A lot of them don't even want people to know that I make the stuff. But I did DG, PGS, Mariner, Jetline, JetSport, Orange County Jet Ski, Butch's Jet Ski, a lot of the jet ski corporations. I mean, every single one of all those reads, FMF, they're all mine.
Yeah. Well, and see, that's the thing is there's always a lot of people on the front end of something that are talking like they do it, and then you dig far enough and you find out that it all comes back to one guy.
Yeah, and you don't know how many times I look at an ad. Or I get a customer call me, oh, so and so said you built his engine, and I'm like, they want to use my name to verify that that engine is good, and I'm like, I sold him parts. I did
Yeah.
not build.
Yeah.
If I built that engine, there is a serial number on the engine. Read it back to me, and I'll tell you what it is. There's no serial number on the engine. I didn't build it.
Yeah. Then it's not mine. It's not
And
mine.
one of the things we did too is we were in the crankshaft business. We were doing 25 crankshafts a day at one time. Typical average was 10 to 15, but I mean, we ran 2 full shifts. So, I mean, I had guys working, I'd come in at 5 in the morning and leave at 10 or 11 o'clock at night. I mean, every day, 7 days a week, it didn't matter. And every employee had what I call an employee number, 1, 2, 3, 4, 5, 6, 7. And whenever they would work on something, an engine or a crankshaft, it had a 1. I was number 1, obviously. Imagine that.
Right.
And it would say 2 and a little circle around it, and it would have a date. So any motor had a serial number, and it had a circle number in it, which told me who built it, and then it had a date on it. And not necessarily needed to have a date on it because the serial number tells me who built it, and it was in my logbook.
Mm-hmm.
And then I kept what I call the little black book, getting off subject a little bit, but the little black book, which is my employees. And I always used to, when something would come back, I knew who screwed up, or I knew who built it. Doesn't mean he screwed up. I need to look at it,
Mm-hmm.
That way I could really control and work with my employees. We were a great team. I had 4 good core employees, and we worked incredible, and we were all working team. That's what matters. Just like you and your daughters, you guys are doing great.
Yeah, I got to beat them and keep them in line. I mean, yeah, they do a really good job. They,
And yeah, back materials, like I say, I will slowly migrate to doing my own testing on reeds as far as the materials. Then you start getting into one of the things that I did is on the flow bench. I would see the thinner materials, the tips. Let's just say like the TRX 250R cage.
mm-hmm.
Um, I would see the tips fluttering really bad. Okay, what that was is back in the early days. Remember, I told you Team Honda and everything. Kawasaki on Steve Mendenhall's 4-wheeler. Basically, actually, it would have been a 3-wheeler. And the KX250 had those 4 pedals. Okay, well, they would flutter like crazy in the flow bench. I would come from behind the pedal on the backside, so it didn't disrupt the flow. And I would just take a piece of wire and stabilize the pedals, and then slowly allow them to come to full open without any tension, so that the pedals couldn't flutter anymore. They would flutter a little bit, but touch the stabilized wire at the back, and the flow would increase. So what I did was take a 4-pedal cage and made it a 2-pedal cage. And then right after that, you would see Honda came out with that 2-pedal cage. I can just tell you some stories.
Right.
I used to color code. You pick up one of my reeds and you flip it on the back edge where the screws are, and you would see a green and a red mark, or green and black, or green and blue. Well, that told me what the thickness of that reed was without having to even measure it. I color coded all my reeds. I would take a Mitutoyo digital gauge to where I would slide the reed under, and check every reed and had stacks of 15,000, 16,000, 17,000, 18,000, then color coded them and then put them all in bags. And then I would use that fine tuning, and that's resin thickness. That's the same, that is the same reed laminate that goes into that giant press that I told you about.
Mm-hmm.
But one of the pre-preg sheets had a little more resin content, had, let's just say 32% versus 30%, and that ends up being a thousandths or so thicker. Now, those thicknesses, there is a slight difference in tension, but not much. It's very minute. But I would get guys that when we get into the very, very fine tuning of a reed pedal to get the frequency exactly where you want it, we would play with that very small difference in increments will make a difference if you, once you've done your testing and you know the parameters where you need to be and you're really close.
Right.
You know, as the motor loses compression, other things, then the reed tension might change slightly. For the average person and the average person running, building motors on a dyno, as long as you're in the ballpark with the reed, it's going to be close enough.
Yeah.
I've already done that research, so you're going to get something that's close.
Gotcha. All right. Well, we're at 27 minutes, so let's go ahead and end this one, and we'll come back. And you want to stay on reeds, or you want to move to something else?
I think let's do one more read.
Okay.
I could focus a little more on the next one will be the tip designs, which we talked about a little bit. We'll do tip designs, things that I've done with the tip of the reed cage and reed stuffers. And then the last thing is positioning of the reed cage. We've already discussed that. How deep in you want to go, how close the carburetor is to the reed cage. Just to be short with it, the closer the carburetor is to the back of the reed cage, and I call the reed cage the focal point of the vacuum, the negative. The closer you get that carburetor into a reed cage, then the better it will atomize the fuel. The speed of the air going through that carburetor is greater. You'll get better performance.
Yeah.
And I made a reed cage that actually had the backside of the manifold was a metal tube that went into the reed cage, and the little groove on the car, I put O-rings in it to where the carburetor would fit in and pop in, and then I had to hold the carburetor in from the backside. That worked out really well, but marketing logistics, manufacturing logistics, it's not worth it,
Gotcha.
Yeah, then we can start talking into reed cage spacers. The farther out the carburetor is, I mean, there's just so much more to go to.
All right. Sounds good, buddy. Well, thanks guys for watching, and we'll be back with some more.
Okay.
All right.